Guillaume Bichot from Broadpeak, who will talk about DVB's toolbox for internet television. Is this also about DVB-I, by any chance?
Partly, yes.
Partly, yes. Okay. Enjoy.
Okay, so this is a joint work with Raphael, that is here. But it also reports work from beyond us, all the members of DVB that have worked on the specifications that I'm going to disclose today, right? It's complementary, this work is complementary, this presentation is complementary with the one presented by Michael. What I'm going to do here is to give you more insights about the specs that he was talking about, right? And why DVB has tackled this, has started this effort a few years ago. So first of all, let's start with DVB. So what is DVB? DVB is very known and very well known as a broadcast-centric standardization body that basically have designed transmission solutions, mostly for terrestrial, satellite, and cable. And the ecosystem is quite simple. You have a transmission system, and then you have on the other side a decoder and a TV, right? It's quite simple, and it has worked for many and many years. 20 years ago, DVB started to do something related to IP. They call it DVB IPTV. It was a closed word, so it was basically about using RTSP to control the playout and defining a service discovery mechanisms, but very closed, not open to internet, dedicated to this system. Anyway, all this is based on MPEG-TS. It's been, and it's still based on MPEG-TS, right? So that represents mostly what DVB did. The footprint of DVB, however, is quite big. Here what you can see on the screen is a footprint for the digital terrestrial TV. It is something, right? So the organization is impactful, I would say. So on the other side, we have internet video streaming. We don't have only a TV, and we don't even use very rarely the TV for streaming video over internet. We use many different kind of terminals. You know them, right? Smartphones, tablets, laptops, desktops sometimes, and so on. We have multiple streaming services, solutions, protocol over internet, and we have multiple options, protocols, like I said. It can be like a bit of jungle, right, for those members from DVB to try to develop their business over internet, right? It can be a bit scary. So DVB decided a few years ago to bring somehow the televisions to internet. So, and the idea was to develop a set of specifications to reduce the number of apps, to keep the experience. So the experience is, you know, the TV zapping, for example, to keep the quality that is very important for DVB, so 8K, HDR, for example, to improve the scalability of internet, over internet, and keep the cost efficiency because the DVB system is efficient, is very efficient in terms of cost. Well, it used to be, right? Because, okay, one drawback, like Michael mentioned, is that MPEG-TS now becomes more and more something costly and more costly because it gets very different implementation and a very different ecosystem than what we used to do and used to deal with over internet. And that's it. So that was the idea. So let's go to internet and let's try to address all these requirements. So basically what DVB did, it says we need to keep the interoperability insurance that DVB is famous for, keep our broadcast ecosystem, keeps the quality of experience that is also number one in DVB, and try to merge it with what internet is known for, right? And we generated we started 4 different specifications. The first one is called DVBI. It's been mentioned by Michael. It's used for discovering TV services over internet. The second one is DVB-. So it's very close to MPEG-. It's just constrain MPEG- to, according to the requirements I just presented in the previous slide, in order to keep MPEG- implementable and ensuring more interoperability in the DVB ecosystem. Scaling and graining the internet television thanks to MABR, and we're going to see why. And then finally, transform completely the broadcast solutions that we have today in order to become fully IP native, sorry. So first, DVB-. Let's be very quick. So DVB- is a profile of MPEG-, like you understood. There is low latency support that has been very well defined jointly with -IF. And there are a certain number of features that makes DVB- much more interoperable, MPEG- much more interoperable within the DVB ecosystem. It improved the accessibility, it improved the terminal interoperability, and it has a lot of features beyond the one that are listed on the slide, and I invited you to read the specification. And all this work, by the way, have been subject of published specification, right? So DVBI. So what is DVBI? It's a simple, well, it's an XML format that permits to implement 2 kind of servers. The first one is called a registry, a DVB registry. It's a way to request a service list. A service is a channel, right? A TV channel, for example. So the DVB registry can be queries to return a URL for accessing a service list. A list of services, right? A server, let's say a URL to access a list of services, right? You can query the DVBI registry by giving some parameters, like, for example, for a particular language, you would like to access a certain list of services for a particular country, and so on. And the second, once you get this service list URL, then you can query the service list server that will return you the list of services. And here what you have, the example that you have is a list of URLs, and in particular -URL. It's very simple to understand, right? And that's it. This is not more complicated than that. And this is already the subject of implementation. There is already a DVBI registry server that exists, and anybody can build it and expose it over internet. And the kind of URL that you will get allows you to stream over internet, but also to stream. You can get an URL that allows the DVBI client to stream over existing DVB networks, like a broadcast network. So let's go to DVB MABR now. So what you can see on the screen is it represents the efficiency of DVB MABR. It's been mentioned already in the previous presentations. It's efficient. It's efficient in terms of usage of the bandwidth. What you can see here is that the green colors, the green bars, is a number of bytes transporting over multicast, and it's quite huge, right? So it's based on, it's a real implementation, by the way, right? So it's very efficient in terms of bandwidth consumption. So let's have a look on what does the spec contains. There are basically 3 modules, 3 important modules. The multicast server that behave like a kind of adaptive streaming client, right? It gets the content, and then it sends the content over the multicast network. And then we have the multicast gateway that receives the content and store it in its cache. The multicast gateway acts as a small cache, right? And then we have the rendezvous service that is somehow the request router. These are the three main elements. So a player starts the sessions by contacting the rendezvous, and if the request makes sense, it is redirected towards the multicast gateway for getting the content. Again, the content is distributed over multicast. So the specs describe the mechanisms I just talked about, and the mechanisms can take place thanks to a configuration. This is very important. It's again a big XML file that is distributed, that is sent to the multicast server and to the multicast gateway, and that allows the multicast gateway to understand how the different representation, the different streams are transported over multicast IP, right? The transport itself is done thanks to a multicast transport protocol like Flute, Route, mSync, and Norm. And there are several ones because we have to consider the market, the regional markets, and what exists in terms of transport protocol. There is also a specification about authentication and tampering protection. We have a mechanisms to repair the missing packets. And there is quite a comprehensive reporting solutions where we describe the metrics and the protocols to report the statistics. And that's it. I'm going to skip this. So basically, let's see what we have. Internet television is about streaming over DVB, using DVB-Dash, again, a profile of MPEG-Dash. What DVB has added is a spec to discover the service over Internet through either a DVB-I server, a DVB-I registry, and a DVB-I list server. And the content then can also be distributed in an efficient way through a DVB MABR. So here you have the four specs. That have the three specs that I've just talked about in this drawing. The last one I want to introduce here is called DVB NIP. Very briefly, DVB NIP is just the idea of using all the protocol I just mentioned, DVB-I, DVB-Dash, and DVB MABR, but over the broadcast network. That's it. So here it is. So what DVB NIP has defined is the encapsulation scheme based on GSC, which is an encapsulation protocol. And on the top of it, you have UDP, IP, MABR, DVB-Dash, DVB-I again. And what DVB NIP has also specified is all the signaling. And the signaling is used to map, to understand what is the frequency, what is the channel, or the hardware, or the frequency, physical channel, how this physical channel is mapped to the streaming content, to the URL, basically. So you have a URL, and you want to understand where I can find the content in physically speaking. And this is what the NIP signaling does. And it used to be based on MPEG-TS with a complex table, and now it is all based on XML files. I'm going to skip this one. You can access the paper. So I would finish with this, again, this drawing. This is the same drawing than before, except now that in orange you can find the DVB NIP color, where you have a configuration and you have a DVB NIP module on the gateway side, on the home side. So, and DVB NIP as specification is based also on MABR, DVB-I, and the DVB MABR gateway, all this module in the same box. And one specificity I would add is that DVB NIP can run without unicast at all. That's it. Thank you. And if you have questions.
A round of applause, please. And indeed, if you have any questions. Yes, there is a question.
So the use of multicast and broadcast is interesting. So it brings us back to the beginning, the birth of television almost. So how many carriers, like in Europe or around the world, support broadcast, multicast across their cellular networks? I've never heard that used in the US.
You would have noticed that I didn't mention the cellular network, right? So when I said broadcast here, I mean broadcast over the air, right? So, which is what I mean, satellite networks, such kind of things, or terrestrial network, I mentioned them, or even cable somehow. But not, well, the cellular, there is a broadcast facility that Michael mentioned, but it's not as popular, of course, as a satellite network, right? So your question was related to cellular, or?
I assumed it was cellular, but I guess
Yeah.
that's not the case. Yeah.
No, that's not the case.